Yeah, so let's. I presume that there must be some questions. Let's get going.
Okay, first of all, I would like to open this session asking about the context school because we know that everybody needs, but not everybody knows about it. And I would like to know how you define this context school.
Well, the context-driven school emerged from a bunch of the context-driven school of software testing. First of all, it's not a like it's not an escola, right? It's not a that kind of school. It's a school of thought and a kind of community, um, or like a school of fish, I suppose, in a way, right? Swimming more or less the same way, and yet there's a deep paradox in it because uh, part of one of the premises of context-driven testing is that there's no one way to do testing. That the value of any context or a practice that we might choose to do depends on its context, the set of factors that influence how we might make decisions or how we might uh, apply certain kinds of skills or certain kinds of tools and that sort of stuff. So it emerged from this group of people who were recognizing that a lot of the ways that testing was being done back then, and still to this day is being done, I fear, is that the idea that there's one right way to do stuff, and that is a sort of normal, technical, orderly kind of process. Now, there were other schools of thought too. One was the quality school. That's how it got named, as something that said, well, geez, if we just get things right the first time, everything will be fine. And we can greatly reduce the amount of testing that we have to do and the approaches to testing that are necessary. Then there was this sort of quasi-mathematical school, which and I'm being a little bit unfair in sort of summarizing these things, but the idea behind the mathematical school is that, hey, computer software is just applied computer science, and computer science is a branch of mathematics, and that we can write provable algorithms, or we can examine the mathematics that goes into a piece of software, and if we get that right, then everything's going to be fine. The dominant school says that the factory school is typified by a focus on, comparing the product to its specification and saying, if the product doesn't match its specification, then there's going to be problems. So what are we going to do? We're going to create test cases, and we're going to have people execute those test cases. And if the product is consistent with what the specification says, then everything's going to be fine. Well, again, I'm being pretty glib and dismissive of that at the moment, and that's not really exactly fair. So in order to be more fair about it, I guess I can put this in the private chat, but James and I several years ago worked on a paper or a sort of outline which describes how RST, which is one flavor, if you like, of context-driven testing, is different. So the principal idea behind factory-style testing is that there are best practices. They go across the industry, and if we follow those best practices, applying those best practices to technological artifacts, testing is just a repetitive process of collecting facts. Well, that's how we're going to deal with testing work. Our perspective includes the idea that the product is a solution to the problem, and if the problem isn't solved, then the product doesn't work. So one of the things we've got to examine in our way of looking at the world, and this just comes off the back of a really recent conversation with James, is we've got to get clear not only on the translation of input to output, but we've got to get clear on what our intentions are. We've got to figure out what the customers of the product and what the business wants from the product. We've got to be clear on, at least in reasonable terms, on how we go about building the product. And where we might examine the product as it's being built in order to determine whether there are problems being introduced as we're building it, easy to find, avoidable kinds of problems. All the way along, we've got to focus on testability and preparation for deeper testing. The deeper testing involving much harder questions, much richer questions than does this particular piece of input map to that particular piece of output. So there are other premises and principles of the context-driven movement. One is that I would say that the dominant one is that the people are the most important part of any project's context. That there are no best practices. There may be good or bad practices in certain contexts, but there's no set of practices that's universally best. There are numerous factors, lots of factors, which affect our choices, our context, and our choices inform each other. Products change over time in ways that aren't predictable. That testing is an intellectual process, not a factory process. And all that requires a judgment and skill. Now, the hardest part of that, of course, is that when there's so many different products, contexts, environments, you get a whole lot of different people with different takes and different perspectives on these things. Therefore, we tend to argue a lot.
And miscommunication.
There's a fair amount of that too, absolutely. But we argue a lot. And it seems to me that there are lots of people who just aren't that comfortable with disagreement, dispute, trying to get to the heart of things with debate. And, feelings are hugely important to certainly to us in rapid software testing. And I think implicit in the context-driven software thing, that's a big deal too, since people are the most important part of any project's context. So it's a hard community to keep together. There's all kinds of, there's centripetal forces that bring us in, but there's all kinds of centrifugal forces that cause us to disperse. So the context-driven community is very fragmented, and it's not in, it's never in any kind of easy container. And so there's something fundamentally paradoxical about it. It's a kind of community of communities in a way. But there, as I say, there are lots of people who are uncomfortable with controversy, but we believe that controversy and dialogue and debate and such are the ways that we get to the good stuff.
Yeah.
In the long run, and it's like kind of painful, and a lot of people have different approaches to dealing with each other, not just to dealing with the issues, and that's made life challenging along the way.
No, what I was saying is that one of the things that I've seen in the context-driven community is that even though we understand the foundations of the school, of the approach to testing, we don't think we don't have the same perspectives at all, and and we understand that that's a good thing because that's how Just Bacon said is that's the way where we get better together, understanding our different points of view and discussing. We are not afraid of discussing as I've seen with the factory testing when you say you don't have to do test cases. Well, how dare you? How dare you not to do test cases?
Yeah.
Or you have to ensure quality. No, how dare you do you ensure quality? So it's something that is. I mean, you need to learn well to discuss, to analyze and discuss, and it's a very important part, I think, for the testing community too. But I don't think we don't put too much effort on that.
It's hard. I mean, by and large, it seems to me most people like their ideas. Otherwise, they drop them. And one of the things that made me a little more comfortable as I entered this community was there were lots of ideas that I was prepared to be challenged on, right? That I was prepared to drop. There's actually lots of people who know more than I do about stuff generally, but there's also lots of people that know different from I do because of their context. So there is really fundamentally a paradox at work here, which is that we all want to be part of the same community, and we're all part of different communities at the same time. But there are some things that I think go above that. And the thing that really sticks for me, certainly in RST, which again is a flavor of context-driven testing, but is not the same thing, is that it's all about the people. We are here to help each other. We're here to serve each other. We're here to learn from each other. And we are not entirely, strictly speaking, rational people. People are not creatures only of intellect and of systematic thought, but we're also very strongly political and emotional animals. And that immediately introduces the notion that feelings and emotions are going to be on the table. And I think one of the things that happens with the other schools is they try to kind of push that aside. Yeah. And we want to acknowledge that and embrace it, because there's a wonderful interview with a guy named Simon Schaffer, which proved really profoundly influential on me. And let's see if I can get a link to at least the first episode. How to think? Sure.
But how to manage this with all team to
Well, there's a way to deal with that, it seems to me, and that is to embrace the fact that we have feelings, and those feelings evolved over generations, millennia of human evolution. They evolved because they protected us. They evolved as a means of signaling. how we feel. They evolved as a means of identifying risk and problems and trouble. If you look at the list of emotions that various lists show up, but very few of them are pertain to happiness. Most of them pertain to danger, disgust, anger, and these are all things that help keep us out of trouble. Now, in rapid software testing, we make this explicit. We use our feelings because we are not simply creatures of technology. We use our feelings, but we think critically about them. And that's the workaround, it seems to me, is to systematically embrace and systematically question and doubt your feelings about stuff. This comes back to the thing that I was trying to get at, and so now I found a link to it. There's a CBC radio series called How to Think About Science, and the first one introduces this, basically the field of this sociology of scientific knowledge, how people in groups and in social groups and domains and so on and so forth, how they come to institutionalize what we know, scientific facts. The people who are researching this were noticing that in the world there was an idea about scientists, and I think this is true about technologists and it's true about testers too, that there was this idea about scientists, let's stick with those, that they're absolutely special people, that they are much more rational and much more skeptical and much more embracing of facts than ordinary people. Yeah, like that, right. So but it took the sociologists looking at the way individual scientists and community of scientists worked to realize that that's not really true at all. That scientists weren't terribly more skeptical. They weren't more logical, weren't more rational. Not really. But they were very good at knowing who to trust. And they were very good at knowing how to set up what Simon Schaffer describes in the first interview as very carefully designed workspaces. And it didn't seem reasonable to believe that social forces work only to wreck or to destroy good science. As Schaffer says in the interview, it didn't make any sense to us to believe that that emotions or feelings or that social forces could only wreck science. If you look at science, it really is that the reason for science's success is it uses social forces so well to come to agreements within community on what constitutes matters of fact. So the interview and the interviewee, Simon Schaffer, expresses far better than I can. But our emotions, our disputes, our agreements are the things that make testing great, not just the technological aspects. Not just the technological. I mean, technology helps us, but we're also questioning technology to see how it might hurt us as well.
Yeah, but there is a process. For the development process, the development team is following a process to develop or to create the software. But in this case, as a testers or the testing team, we shouldn't have a process to follow to do the test. I mean, we should let it go, feeling and understanding the business and understanding the risk and the application and the meaning of the application and everything around, but I don't know if we can follow a process with that.
Well, first of all, what do you think? There's a couple of questions I want to ask you, since it's Ask Me Anything.
Yeah.
You didn't say who me was.
You cannot ask questions.
What is it?
No.
We will ask the question. What is the process to you, Daphne?
Here, Andres knows, but and the ISTQB girl, but I mean, and not the ISTQB. I mean, and
what do you think? What do you think? I don't care what the ISTQB says, because the ISTQB, it seems to me, doesn't follow a very good process for determining.
No, actually, no. It's only the ISTQB.
What is the process?
But I mean, I'm not talking about what the process I'm following right now. I'm talking about what the industry of softwares follows some process. I mean, when you start working in testing, they say, well, you need to analyze the requirements, then write the test case, then execute the test case, then report the bug, then please retest the test case, then please give me the final result, a report. That's the process that we follow. And
is that a process or a process model?
Process model.
It's a process model. Okay. So what's the big deal about the difference between models and, say, reality?
That's it. That's the reason I said sometimes it's difficult to follow that or to do a good testing, because you need to follow that model. Oh, you are forced to follow.
First of all, okay. So the first thing that I would kind of object to on that is that models are only representations of reality. They are not reality. And in that sense, the process is what happens. Okay, that's the first thing. Mm-hmm. Second thing is, and this is, I think, implicit in context-driven software testing, but it's definitely explicit in rapid software testing. Process models are applied, not followed for us. We don't follow a process model. If we consider a process model, we apply it, but the application is in the minds and the hands and the actions of the people who are applying that model. The people are at the center of the thing. Now, when we say, oh, we're following this process model, is anybody actually looking to see how things really happen? For instance, there's this idea that you get a requirements document, and then from that you generate test cases, right? Mm-hmm. Okay. Is that what really happens? Have you ever seen somebody sit down and say, okay, give me the requirements documents. Okay, now what I'm going to do is I'm going to turn those by some magical process into a bunch of test cases. And then I'm going to execute those test cases, and I'm not going to deviate from the behaviors that are prescribed by the test cases. I'm going to do exactly that. And if it comes out that this condition that we're observing here is matched by what it said in the test cases, then we put a little green check mark next to it. And if it doesn't, we put a little red X next to it. Is that the way things really happen? Of course it isn't. Of course it isn't. In fact, there was an example of that. There's a nice example of that in some of the RST material that pertains to it. Let's see if I can just bring that up and get it out onto the screen here. Okay, we're testing a product. We're making a product, and we need you to test it right away. Right? Somebody comes to you and says, oh, we're testing a product. We need you to test it right away. So what do you do?
Yeah, but what do you mean by testing? What do you mean by testing, Daphne?
Oh, yeah, you're not supposed to, you can't be asking questions here.
Oh, yeah, I'm sorry.
Somebody's saying to you, we need you to start testing right now. Well, but that's the first thing you do, isn't it? The first thing you do is say, wait, hang on. What do you mean? But the process models say this. The process models say you prepare test cases and then you execute test cases. It's easy. Well, hang on.
Well, it sounds easy.
Well, it sounds easy because maybe it's more like this. We read the acceptance criteria or the specification, and then we identify specific items that have to be checked, and then we prepare test cases, and then we execute test cases, right?
Mm-hmm.
Yeah, right.
Well, maybe.
Yeah.
Maybe it's more like this. We read the spec. Oh my God, there is no spec.
That's
Or
right.
it's incomplete, or it's incomplete, or it's not clear.
Oh, hang on. Yes, that's right. There is a spec. There is a spec. It's like 19 folders down on some server that we just discovered somewhere over there. There is a spec. Thank God. Let's have a look at it. Oh my God, it's old and it's confusing and maybe it's wrong.
Yeah.
And then, I know what I'll do to clear it up. What I'll do is I'll go and I'll ask somebody. Now, in the process models that are prescribed by various development organizations, various ISTQB style models, what happens when you ask somebody? They just give you the right answer, and then you can go back and you can write your test cases. But in reality, what happens? Oh my God, nobody knows how this thing's supposed to work.
Yeah, that's true.
Yeah, I will respond. How much time do we have? I'm busy, man.
That might be a really good thing, right? For example, yeah, you want me to test something. Hang on, what's my mission? What do you want to know about this? Because there's stuff that I presume that you already know about and that you're sort of reasonably confident about. Maybe that confidence is warranted, maybe it's not. But can you tell me what the risk is here? What kind of problems do you have in mind? What are you worried about that you actually want me to test this? Who are the developers? Where are they? I mean, if there isn't a spec that we can read and trust, source of truth, right? If there isn't one of them, what else can we do? What are the developers doing? What's my relationship with the developers? Do I have access to them? Because that's a context factor that's going to guide my choices, my actions, and so on. So, is this thing finished? Or does somebody believe that it's finished? Or does somebody believe that some part of it is finished? Because, okay, if we got the whole product, we can test the whole product. If we don't have the whole product, maybe there's a mock-up, or maybe there's some work in progress, or maybe we don't even have the product yet. There's a document that describes the product. Or maybe there's a diagram that we can look at and that we can analyze, and we can say, okay, if there were a problem here, what kind of problem would we see? Or maybe there's a feature, maybe there's a function that we've got that we could examine. Or maybe maybe we don't even have any of that stuff yet. Maybe we've got to prepare ourselves for testing by testing something that's like this product, so that when our product comes along, we'll be better positioned to test it. Maybe all we've got is a set of ideas that somebody has for the product. So rather than a process model that involves an assembly line, in RST at least, we've got something that looks a lot different from that. It's a set of questions, the questions that you proposed there, which is, wait a minute, are we sure we know what everybody wants from this thing? And then as we're in the process of building the product, we might be asking, well, are we building what we think we're building? As we're getting ready to test, we're asking ourselves, well, okay, we're getting ready to test, but are we ready to test deeply and efficiently? And then when the testing is going on, the question we've got in front of us is, all right, have we tested enough to know about every important bug that might have got away from us? Well, rather than thinking in terms of a process, or a process model, what we might think about is a set of framings for testing. We have this idea about, well, we have this question in our minds, which is, are we sure we know what everybody wants from it? So in that frame, we think in terms of questioning, analysis, review, not experiments with the running product. We don't have that yet, but thought experiments. We might call that sometimes prospective testing. If there were a product like this, what problems could exist in it? Or to put it another way, I did a summary talk at Eurostar that there's a video that describes this, but basically 5 questions. What are we building? Who are we building it for? What do they want from it? What could go wrong? How would we know? So that's not a step-by-step orderly kind of thing. That's something that's going on all the time. It's an ongoing set of processes. And then as the builders are building the product, we probably don't want to test too deeply, because then in the middle of building it, and testing too deeply is going to slow down the developers if we get them to do that. So what we do in collaboration with the developers sometimes, or what the developers might do on their own, is the kind of testing that tries to identify easy to find, avoidable errors in the building of it. And the object of the game is not to find every deep problem, but in a way it's to find problems while they're still shallow, still close to us. So testing for problems that we can see really easily at the surfaces where we're working. And testers may be involved with that. Developers, I believe, should be doing that. Sometimes they are, sometimes they're not. But the key is for developers, and in collaboration with them, maybe testers, to do work that's not going to disrupt their flow, that allows them to make fast forward progress. All the way along, we got to be thinking about, well, wait, have we got our intentions right? Are our intentions expressed clearly enough that when we get into the last frame, the one in the top left there, are we going to be able to test efficiently? Is there testability, intrinsic testability built into the product that would allow us to know if something were going wrong? And then the final frame is the realization frame, when we've got something that is deemed to be a real thing, a real function, a real product, something where we've realized our goal in some sense, or at least we think we have. At that point, that's time for realization frame testing, which is experiential, experimental, exploratory in ways that are deeper than you can do in the bottom right corner, but in ways in which we will find the problems that are more rare, more deeply hidden, more subtle, more intermittent, more emergent, and more elusive, the kind of problems that might have got past what would otherwise be a very disciplined development process, because those problems do happen. And have a very disciplined development process that, because we're taking a bunch of complex components and a bunch of complex technologies and a bunch of complex domains, we're putting them all together, there are problems that are going to emerge from that, problems that we didn't anticipate, that we couldn't anticipate, in exactly the same way that you can't anticipate what a tree is going to look like by looking at a bunch of seeds and a bunch of soil. So, Daphne, rather than a process to be followed, this is a set of ideas to be examined, and a bunch of experimentation to be done. Because here's the thing about software development that people don't seem to pay very much attention to. And that is that software development is not a linear process, is it? I mean, when we look at those things that I was talking about on a project level scale, well, we could say that this is what testing is look like, just these loops. And the way to handle that is to take those four things and just do them in order. Well, we could do that, but that's not the way testing really works. That's not the way development really works. Development is not linear. It's not even just loopy. Development is a fractal. Now, the kinds of process models that we see in the factory model of software testing, those models seem to be really, really linear. But we're constantly being interrupted. We've constantly got new information coming in. Our experiments lead us to realize things that we hadn't noticed before. We're learning stuff all the way along. A component that we thought was fine turns out to have vulnerabilities or problems in it. Now, what we could do is we could talk about end-to-end testing, but where's the beginnings and where's the ends? Our contention would be that real end-to-end testing means that every little bit of the product and every component and every set of integrated components and the whole product itself, that gets tested end to end at every scale, because each little thing we do has these four notions of testing that we might apply to it. Testing our intentions, testing as we're building the thing in the discipline frame, considering how there might be problems lurking in places and how we can make the testing process more efficient, preparing for testing when we've got something real that we can work on, something where the developers, one way or another, believe that they're done, whether it's at a little tiny one-line change scale or at the entire lifespan of the product. Each perspective we have on the product can take a form in which these four things apply. That's my contention anyway.
Now it's more clear to me.
I'm going to quit my certification.
That's right. Actually, we have some questions for the audience. If you want, I can show you here.
Sure, yeah.
There is the first question that, are you and James splitting up responsibilities for writing, taking testing seriously?
One way you could think about it, I suppose, is that James is the developer and I am the tester on the book. James is a quite prolific writer when he wants to be. So am I. But James's name is first on the book, and that's great because that means I don't have to write anything if I don't want to. But in all seriousness, that's pretty much the way it's been working. That James will produce a bunch of text. There's most of the time, not always. James will produce a bunch of text, and then I will review it. And my role is kind of like the role of a tester in the face of a developer who's doing some work. And the important thing about that is that here's how testing feels to most developers, and here's what James's life feels like to him when he's written something that's time for me to review it. It feels a lot like this. Now, I'm the one holding the little bowl full of water there, and you can see it even actually. It looks not entirely unlike James, that dog. But that's how most of the work has been going. Another thing that I've done is I've taken several of the I've taken an interview approach to a couple of the parts of the book, and I've been editing those interviews, performing the interviews sometimes, and then editing them and getting them into a form that is publishable. And that takes a lot of work. I had a 3-hour conversation with Keith Klain that I think took something like 40 hours to rewrite. So that the conversation is, the way I've been joking about it is, it's Keith describing his approach to testing in his own words, just not the order in which he said them necessarily. And that's kind of what the process of writing a book is like generally. There's a bunch of ideas in our minds and our heads and so on that are sort of vague and incoherent. And it's just this continuous process of refinement. One of the reasons that it's taken us so long to come up with a book is because our ideas keep, in our own minds at least, getting sharper and sharper. And then the world comes along and brings in something new. So, in 2013 or 2014, there was this huge drumbeat of stuff: automation. So we had to respond to that. We wrote a piece on that, and that took us a good long time because we're fussy. And now, heaven help us, it's AI. So we are, testing itself, but also writing, development, software development, writing. All of this is a process of exploration, discovery, investigation, learning, and it follows that same fractal loop that I showed before. So that's how we're getting it done anyway. James is the lead writer, and I occasionally contribute longer passages of material. But my principal approach is to be the tester to James's developer.
Once you're a tester, you're always a tester.
Yeah, it's easier for me, man. Well, James, when it comes to testing work, James is also a much more enthusiastic coder than I am. I write code, and once I'm into it, I kind of like writing code. But boy, oh boy, is it ever a fussy and annoying process, especially when you don't do it every day. If you don't write code every day, at least 3 things are changing. The product is diverging and twisting and turning. So you got to keep up with that. But the tech stack is doing that too. So every time I sit down to write some code, there's 7 libraries that have to be updated. And then, I'd love this. There's a new version of this library available, so I install that, and then immediately the next thing that happens, if it's Python, is that there's a new version of pip install too, or of pip is available as well. And that sort of stuff, for me, it always feels like being pecked to death by ducks. I just don't have the patience to be an enthusiastic programmer all the time. But then as soon as I get into a project that I enjoy, some work that I like, I'm on that like a dirty shirt. And my wife can testify, I disappear for days on end if I'm trying to build something.
I have a question. You have a question? Okay, so go.
Another question for the public. So, and then your question.
Remember that Michael has to leave at 10 o'clock.
Yes, I know.
Yeah, actually, a couple of minutes before that, if I'm going to cause the organizers not to panic. What do I consider the most underrated soft skill that's important for a tester with a certain level of seniority? I would. I think I would decline to answer that on the basis of the in the question, because I don't think there's just one. I think it's a great example of a context-driven way of answering the question. Here is a list of skills and tactics that excellent testers have. And I guess another problem I have with the question is this notion of hard versus soft skills. For example, a diagramming. That's a particular weakness that I have. I wish I were better at diagramming. And it's the sort of thing where if I bothered to practice it more often, I'd be better at it. So that's one. Summarizing a complex system in terms of a diagram is a really, really valuable skill. But is that a hard skill or a soft skill? I don't know. Certainly, the skill of reflexive critical thinking. How might I be wrong? That's a skill that's worth exercising, and there are tactics that you can apply to learning that skill. Time management, negotiation, diversifying your perspectives. All of these are things that could apply to anybody and to everybody to some degree. But here's a heuristic, which is take something that you'd like to be better at and you're not really quite comfortable with and plunge in. Give it a shot. And maybe one of the soft skills that I think it is a skill that can be learned, at least, is the skill of feeling like an idiot, feeling incompetent, and working your way past that.
Yeah.
Working your way past that. Just recognizing I'm not good at this, but anything that you are good at, you weren't good at before. There was a time in the past when you weren't good at that. I'm pretty good at playing the banjo now. I've been it comes out because I have to take it in. It's broken just now. The part of it fell off just the other night. But just dealing with the fact that I'm not good at it yet. And as soon as you acknowledge that part of getting good at something involves, starts with being bad at it. And we've got that in our materials too. Any process or skill or technique that is done both well and efficiently starts out by being done poorly and inefficiently. And therefore, getting it right the first time means it's a dream. But most of the time, either it isn't right, or it wasn't the first time, or it was trivial. It just wasn't a big deal at all. Or getting it right the first time sometimes means you got lucky. And here's a personal thing. I got really lucky when I was born or brought up to have a reasonably sharp and prodigious memory. I got lucky. There are ways of enhancing and developing your memory, and that's a skill too. But usually, something that is desirable takes time and it takes practice. And the first step towards that, I think, is just embracing the fact that it's confusing and that the confusion is normal. And confusion is necessary, and we can lean into it and just recognize, we're not going to be very good at stuff. And that's the wonderful thing about kids, is that kids don't really notice and don't really mind not being great at stuff. And somewhere in our enculturation, in our biology, we learn stuff and we forget that we didn't know it before. And then when we're adults, we lose our sense of comfort. We become self-conscious and so on and so forth. So maybe my candidate today for what's the most underrated soft skill is the ability to relax into confusion and learning. And look at this here. Look at this thing here. I have to go through this book, right? See that book there, Understanding Deep Learning? Look at how Understanding Deep Learning. Oh yeah, it's enormous. It costs a fortune, and the type in it is pretty small. And there's a lot of really dense math in it, and I'm still working my way through parts of it. Some of it I was familiar with before, but this is a really deep dive, and my brain hurts, and that problem will go away. My brain hurting, that problem will go away in the long run, but it's going to take time. Relax into it. We got time for one 60-second lightning round question.
Go, Andres.
Okay, in 60 seconds, Michael, tell me, what can we do for people to stop talking about manual and automated testing, to give more importance to the tool, and to stop talking about how AI can do testing for us? Can you do that?
Sure. The first thing is, the reason people keep talking about manual testing is because they're not very specific about what they're talking about. When we're talking about manual testing, we propose at least three things. One is interactive testing, where the tester has to be present and interacting with the product in order for the process to go well, versus unattended testing. And now testing is never really unattended, but there are parts of testing work that can be unattended. You can start a process and let it go off and come back and examine the output and so on and so forth. Instrumented testing, where that gets in the way of experiential testing. That literally gets in the way, not as a bad thing necessarily, but distinguishing between experiential testing, where the experience of the person using the product is almost exactly the same as the tester's experience, and vice versa. The difference being that the tester will be looking at this in an analytical way. And if the tester encounters a problem, the tester says, "Cool," and writes down a note, whereas the person using the product will say "shit" and get frustrated and angry. So attended or interactive versus unattended, experiential versus instrumented, and exploratory versus scripted. Say those things. Use those words as plug-in replacements for manual testing, and maybe some of this problem will go away. I guess I could give you one more a general thing on talking about testing, but I think I'd have to go to my site in order to do that. So let me do that real quick, and then I got to say goodbye to you all. I got a question for you. When do I get to come back to Mexico?
Next year.
Next year. Next year. Are you ready?
Yeah, and it doesn't have to be Mexico either, I want to be Mexico.
We can meet in another region.
Only Mexico. It can be anywhere in the Spanish-speaking world. There we go. All right. Thank you so much. I got to run.
Yes.
Yeah.
Thanks a lot, Michael. We really appreciate you being here.
Thank you. Bye-bye.
Thank you. Bye-bye, Michael.
Thank you.